which option correctly identifies the properties of a liquid? Okay, so a liquid has a definite volume. I mean, if you pour out 100 mils of water, it's not going to change suddenly to 200 mils of water in the new container. Okay, whereas a gas, if you have 100 mils, or 100, maybe a cubic meter of gas, if you put that into a new container, which has the same pressure, but suddenly, twice the volume, then suddenly your gas is twice the volume. Okay, so that's what we mean by an indefinite volume. So gases can take up different volumes, whereas liquids don't generally do that. They just find one liquid, one volume, and so regardless of the container size, the volume remains the same. So it's not C, because it's the only one that doesn't have a definite volume, so it can't be C. Now, A, B, and D all say cannot be compressed, and that's true. Liquids generally can't be compressed unless you use crazily high pressures, and then you can compress them a little bit. So cannot be incompressible is generally a good approximation for normal applications. So we can't decide yet between A, B, or D. Okay, but now the third one, we could definitely narrow D out because liquids don't have a defined shape. Okay, Bruce Lee said it best in one of his interviews. If you pour water into a cup, it takes the shape of a cup. Pour it into a teapot, it takes the shape of a teapot. So if you are familiar with Bruce Lee's interviews, you would have known that. But definitely liquids don't have a defined shape. Okay, they change shape. Even a martial artist like Bruce Lee could tell you that. So it can't be D. Then it leaves us with these two. Can or cannot diffuse. Now liquids can diffuse because they can move from place to place based on the concentrations of liquid. So that happens in our bodies. It's called osmosis, when water moves from one place to another through our cell membrane. So the answer is B, they can diffuse. Okay, so definite volume, cannot be compressed, and can diffuse. Which of the following incorrectly describes electrons in an atom? So we're looking for the one that's false here. So the electrons move through a relatively large space outside the nucleus. Okay, that's true. And by relatively large, we mean in comparison to the electron. So they actually move in quite a big space relative to their own size. So it's not A. Electrons are attracted to the nucleus by electrostatic forces. Yes, that's true. The nucleus is positively charged. Electrons are negatively charged, so they will attract each other. The number of electrons in an uncharged atom is equal to the number of neutrons in the atom's nucleus. Okay, that's definitely not true. Okay, so we can just look at D in case it's slightly more untrue. So electrons are negatively charged particles that have very little mass compared to a proton. That's true. Electrons are negatively charged and they're very, very small compared to a proton. So it'd be like looking at a satellite in space compared to the mass of the Earth. Okay, so this one's true. So this one must be our answer, C. Okay, the number of electrons is equal to the number of protons in an uncharged atom, not the number of neutrons. Okay, so you should have known that from your studies. One of the isotopes of oxygen has 9 neutrons. What is this isotope's atomic mass? Okay, so it's simply just 9 plus the number of protons. So how many protons does it have? Well, if you look on your periodic table, which you should all have with you, you'll see that oxygen is given the atomic number of 8. So if you add 8 and 9, you would get 17, and that should be your atomic mass. Okay, that's your atomic mass. The mass of the protons plus the mass of the neutrons.